Today we are going to go over the 5 most common functions within the Go's standard library. There are also versions of these functions which take a context as an input parameter, but we will cover only the non-context versions. If you are familiar with Go's context, you will understand why this might be useful, and if you don't, please let me know if you would like me to make a video about contexts in the future. For this video, we will be using a Postgres database which I have running within a Docker container on my local machine. The database is a DVD rental sample database which consists of 15 tables, and the main one we will be working with today is the actor table, which has 200 rows. We have also modularized the database connection process within a module called PostgresDB. The create connection function here initializes our database pool and assigns it to an exportable variable. Heading back to package main, you can see that we initialize the connection here and assign the connection pool pointer to the variable db. Remember that the DB type is safe for concurrent use by multiple Go routines, so there is no need to run the SQL open command more than once within your application. If you are interested in how to connect to a database using Go's standard library, please check out my other video which will show you how to connect to most modern databases using Go's database SQL package. The first function we will cover is the exec function. The exec function takes a query string and one or more query parameters. This function will not return any rows but will return a result interface. The exec function is a good option when dealing with insert, update, or DLL commands. In this case we are using the exec function to create a new table within our database. I also did not use a templated statement, which is why you only see one argument passed into the function. After it executes, we can see that the new table has been created within our database. Also, I have printed off the results. You can see that this interface consists of 2 functions, located at these 2 memory addresses. The second function is the QueryRow function, which takes the same arguments as the previous function. A query string and one or more query parameters. However, this function will return a single row, so you will probably use method chaining and immediately scan the results. In this case I will scan the results into my variable number of actors. After it executes, you can see that the number 200 is printed to my terminal. The next function is probably the function you will use most often since it's best suited for select statement queries. The query function takes the same arguments as the previous 2 functions. A query string and one or more query parameters. This time I am using a parameterized SQL statement, which is why the function has 2 arguments. An important note here, for Postgres a parameterized SQL statement uses the $number format. Other databases such as Snowflake use the question mark format. You may feel tempted to use just the SMNT function to create your query string on the fly, but parameterized SQL statements help avoid SQL injection attacks. You should also note that parameterized SQL statements do not require single quotation marks around the placeholder variable. Now back to the query function. The function returns a rows type variable which contains the result of the query. You can access the results of the query using a loop and iteratively scanning each value and appending it to a previously declared slice. The last database query function is the TX or transaction function. Unlike the other functions, the transaction function is returned by calling db/begin against our DB connection. TX is an in-progress database transaction, which means that the transaction must end with a commit or rollback call. The TX function has the same database query functions as we previously discussed to include exec, QueryRow, and query. However, one important note about the TX function is that you can send one or more database transactions, but none of the queries will be saved until you commit the transaction. This means that you need to be careful when crafting a transaction. Specifically, you need to make sure you deal with rollbacks when handling errors or defer the rollback. When you defer the rollback, it will ensure that the rollback is called after the surrounding function returns. This means that when the transaction is successful, the rollback will be executed after the commit, rendering the rollback redundant. However, when there is an error, the function will return without reaching the commit command, thus rolling back the transaction. In this case, we are using a transaction to see if the actor Julia Roberts exists within the actor table. If she does exist, we will print found one record Julia Roberts to our terminal and exit the function. In the event she does not exist, which will return an SQL error or no rows when we attempt to scan the results, we will proceed to insert her into the actor table. This might seem like a trivial example, but in the event you are using a database which doesn't enforce primary key database constraints, such as Snowflake, then you may need to craft transactions to ensure you conform to your database model. When we execute this function for the first time, you will see that nothing is printed to the terminal. This is because an error "no rows" was returned when scanning in the results, thus, we proceeded to insert and commit the transaction. However, if we run the command a second time, a nil error was returned, so we printed "found one record Julia Roberts" to our terminal and returned. After the return, the defer rollback was executed, thus ending the transaction. Next, we will use the Stmt function to ensure the insert statement was successful. The last thing we will cover is the Stmt function, which is Go's implementation of a prepared statement. The Stmt function is returned by passing the templated query string into the prepare function. The Stmt function has most of the same methods we previously covered, including the exec, QueryRow, and query methods. It does not implement the transaction method. However, any prepared statement declared within a transaction will only be available within the transaction itself. The Stmt function can be used in many ways. In our case, we are going to verify that our insert statement was successful from the previous transaction function. Unlike previously discussed functions, we no longer need to pass the query statement as a parameter. Instead, we pass in the value which should be substituted within the prepared statement. The interesting part of the Stmt function is that it will remain usable for the lifetime of the underlying database connection pool. This provides you with a lot of flexibility when organizing your Go application structure. Also, if your application must deal with several databases, the Stmt function can help simplify your application, since you can create a series of exportable prepared statements which are linked to their respective database connection pool. Finally, when we execute the function, we see that we have found the row we inserted during the transaction function. Alright, by now you should have a good understanding of Go's most common database functions. If anyone has any suggestions for another video, please leave them in the comments. If you found the content useful, please give this video a like and subscribe to the channel, since it keeps me motivated to make more videos. Thanks for watching, and I'll catch you in the next one.